Okay, we're going to take a look at practice problem 9.5a. The dimension that is going to define the center of mass is going to be this vertical dimension. So we're going to have to set our mate relations and keep this reasonably aligned so that it doesn't shift uncontrollably. So we're in millimeters, grams, and seconds. The assembly doesn't really care uh, whether we're an inch or um, metric, but when we come to add the dimensions, we're going to have to make sure that we're giving it a metric dimension. So insert the base at the origin, inserting components, coincident, concentric, tangent, parallel, and distance. And then the next one, so one of the recommendations that I give often for the actual CSWA exam is go ahead and look at the next one and see if there's any difference. Basically the same thing, but the dimension changes, which changes the center of mass. And then the third one will change the dimension one more time. So for our purposes, my assignment, I'm also going to do the exploded view and the drawings. So um, we want to go through the process from taking the parts into the assembly and all the way through creating the working document. All right, so insert the base at the origin. On the previous videos, I've been saying click the check mark so that it goes from part origin to assembly origin. So we'll browse over to find my folder here. So we'll grab the base and oh, I don't know what that was. All right, so if we just go check mark, then it's going to snap from the origin of the part to the origin of the assembly. If the part is drawn in the correct orientation, then we can go ahead and check, do the checkbox. If we need to rotate it, then our show rotate context toolbar, which is this little guy, is going to come up, and then we would be able to rotate about whichever axis. If that does not come up, it's not checked, then you can right click and you will have access, but you'll have to right click each time that you want to rotate it. So what I haven't done is what happens if I click out here somewhere. Oh, it did something. It jumped to the base. Let's see. Nope, it jumped a little bit further. So under our view, we can view the origins and notice that the origin of the assembly is not at the origin of the part. So when we go to do our mass properties and come up with that center of mass, we're going to be skewed just a little bit. So let's run through that process, getting into the workflow of bringing parts in, deciding what can be sub-assemblies, kind of going through that the mental gymnastics of how do I want to organize all of this information, and then at some point we have to be able to have a known point to take our information from. All right, so worst case, I could create a coordinate system, an independent coordinate system, but I don't want to do that just yet. We will review that, but under the right mouse on the component with the F, the fixed, we're going to float, and now this is able to move. So notice that it moves in relation to the origin, and if we do a control pan, then, well, the origins disappear, but notice the origins are staying in relation to each other as we either rotate or, well, possibly moving, that there is a perceptual problem that um, very often you can think you're moving the part, but you're moving the view, so, or vice versa. So I'm gonna go, let's do the mate, the paperclip first. And when we're in the paperclip, we don't have to hold down the control button, we just have to select. If your flyout is collapsed, then we want to expand it so that we can see the selections. So the bottom of the base to the top plane, and poof, it goes away. And then we can either check mark, or check mark. And if the mouse shows up with a check mark on the right mouse button, then we can also do that. So too many ways to do everything. For the front plane then, and we're going to expand out, find the front plane of the part, and then there it goes again. And then lastly, we will right plane and, oh, I need to, oh, didn't accept it. All right, so let's go right plane and make sure that gets accepted. All right, so I don't know why that didn't click. Maybe because I was on top of the flyout. So just watch and make sure that it gets applied. So in the mate references, we're going to see those three coincidences. If I need to edit any of those, I can highlight them and it will put me back into that selection so that I can add, remove, or do whatever I need. So we've been exploring the crossover to the 3D Experience XDesign, and we're not seeing a lot of the advanced mates. So I'm going to go through this one. It doesn't really require the advanced mates. There's a couple things that I would do because the with the advanced mates in this one, but it isn't 100% necessary. So we're going to stay with uh, our um, our selections. So right now, no other parts are open, otherwise they would show in the list. And so it automatically jumps to the open. We have multiple ways to bring these parts in. So we'll show this one, the bottom linkage. And as a general rule, I will, and let's see, the orientation is okay on that one, so we can just drop it. As a general rule, I will bring in all of the components. Let's clarify that. I will bring in one component at a time and perform the mates. And when I have all of the components in that I need, then I'll worry about hardware, the pins, the screws, the fasteners, nuts, bolts, washers, all of those will be a secondary, because if in the design there's a revision or something changes, I don't want to have to go through and change all of the hardware after I've gone to all of that work to bring it in. All right, so the select control select, selecting a face, rotating around, holding down the control button, selecting another face, coincident. And then I really like the planes and the faces. So even the cylindrical face, hold down the control button and select. Lost that one, so let's go again. Make sure that I have two things selected, and those are going to be concentric. The pop-up is to lock the rotation and flip the mate alignment. So flip mate alignment turns it over. No, I don't want to see the affected components. And well, that was an example. So to get it back, I'm going to expand out next to the bottom linkage, look for that concentric. It doesn't show up on just the left mouse button. We have to go to the right mouse button to get the context menu to flip the mate alignment. We're going to get the same warnings. If I say yes, it's just going to show me a box of the with the other mates that were changed. All right, so starting to get little blue dots for the origins. Those don't really help me, so I'm going to go back and turn those off. So what I'd want to do is, if this was enough smaller, if I just highlight those two, I'm going to get a normal distance down here, or I could go into my measure tool. And the measure tool, well, now I lost it, but if I went into the measure tool, I've added this one. If we go back over to the evaluate and to the measure, that will give me a distance. So if there was a gap in there, or gap tolerance, we would look at maybe doing a distance mate to center that component. All right, so the advanced mate would be width, but we can always do that extra step of doing the calculation if we need to. All right, bringing in the next bottom linkage. If I select, hold down the control button and drag, I will get another instance. Remember that the instances 1, 2, if I delete one of these, it's going to continue 3, 4 as I bring more in. Or if I've added a bunch of them, then they will just go in sequence. But those are just instance numbers. They're not doing anything special. So let's go with the select control select and concentric and select. Hold down the control and select and coincident. All right, so we need to bring in our next piece. Let's see if my Windows Explorer is still up. Maybe I can shrink that a little bit. There it goes. No. All right, so if Windows Explorer is open on another screen, then I need the top linkage, and I can drag and drop that from my File Explorer and bring it into the assembly. So let's keep going with our mates. Now you can do the edge mates, but again, it takes a little more to select. And when we've applied that mate and we start to move this, because they're not, the relations maybe aren't fully defined, it's going to move in strange and unexpected ways. All right, so we did the control drag from the features, from the components. Let's select the component in the work area, and this is the one you have to be careful of because you will have components start popping up. So we want to control drag and let go, and then we can go ahead with our mates. So let's do an edge to edge on this one. So actually I think it's going to be that one just for, nope, they're on the outside. So outside to inside, I don't think it really matters, but just to stay consistent. All right, so let's see what that one actually added. All right, so we have the concentric, and we're still able to move. If that was a mate reference, I would have got the coincident and the concentric at the same time. So select, control, select, coincident. We still have kind of that weird movement going on, and everything is underdefined because it's still capable of moving. So let's go with, if I open the top, all right, so the top is reversed, all right, or upside down to what we need. So I'm going to do a control tab to switch between the documents. And File Explorer inside of SOLIDWORKS shows the open. So be careful with this one because there are times where everything highlights, and then when you drag it in, it brings in duplicates of a bunch of stuff that's already there. So the base, the bottom, and the top linkage are in memory. They're open because they're open in the assembly, but the top is actually a part file that is open in another window. So it has the darker. So if I bring that in, I'm not really getting the rotate windows. So we're just going to go ahead and bring that in, and that looks like I'm about to reverse it. So let's just click out into the work area and try again. And we'll go concentric. And this one is going to be an inside. So let's go ahead and make that coincident. And then if I can rotate it a little bit closer, I will, but if it's not going to cooperate, I'm not that worried about it because when I apply the next mate, as long as it doesn't lose its mind and completely invert, then it will work a little better. All right, so let's go with the parallel. And the parallel will either be to the base or to the top plane. So applying parallel. And now if we move this, they should move kind of in, nope, no symmetry. So we're going to have to include the through rod to get those examples. So let's go back to, I would like to have another example of one. So the through pin and the through rod. So this through pin, let's go to the window, and if I tile vertically, let's see, I don't need the top in that mix. So that is going to be over here. So if I select carefully from this window and drag to that window, this is going to do an automatic mate reference. So I can bring that one in, and that is a quick way of generating the mates that we need. So we're watching that push pin or that pin symbol. Always think of it as a marshmallow on the end of the stick. If I hit the tab button, it's going to reverse, and we can apply those mates very quickly. If you don't get that to work the first time, just go ahead and bring it in. We're going to apply the concentric mate, the coincident mate, and then these are going to be able to rotate until we bring in the through rod. So let's go ahead and insert a component. I guess the last one I should mention is, we haven't used it yet, is we can go insert component, existing part, and it does the same thing as the insert component. So we'll bring the rod in. That's not exactly the way that I want it, so we look at our reference triad, and we're going to rotate about Y, and that gets it a little bit closer. And we're looking for those two to be concentric. All right, so in that case, I don't know why I didn't get there it is. Maybe I didn't wait long enough. If I don't get the pop-up, then I can either reselect it or have a little more patience, but just keep in mind we can always go back to the paper clip, and it's picked concentric. So let's see, let's go ahead and accept that. There was one more location, so there's a lot of ways to approach these. So if I right click on the component, then go to the mate in the context menu, and go select the rod, then that one will get us there as well. And then we do have to watch for tangent, because tangent is the one that finds strange solutions if we're not careful, or stranger solutions. All right, it looks like the opening of the through rod is facing down. So if we go top plane and top plane, then we can go parallel. All right, so doing that now, when this goes up and down, we're seeing the movement is pretty smooth. It's not trying to misalign. So we'll go ahead with our last pins. So I'm just going to stay with the insert component, bring in the pin, and let's just start at the bottom since we have a few of these. I do want to do the mate reference. So I mentioned the mate reference several times. Let's see what this will do on the face. At the very least, I could get it to get the first concentricity, but if I can get the edge to align, then we can set a mate reference and default and any. So default is based on the selection. If we pick the cylindrical, it would be, we could default it to tangent or default it to concentric, and then aligned, anti-aligned, or closest. So any just says whichever one we get. So since this one's already in place, let's go ahead with the concentric and the coincident. Make sure I have both of those selected. And since I did not lock the rotation, I'm looking at the mate, and the concentric icon goes filled when it is locked in the rotation. So it's not critical, but if you're doing error checking and looking for all of these to be fully defined, then those will be one that you'll have to recognize that it's hardware, that it's able to rotate. All right, so I was kind of expecting that one to jump. So the mate reference didn't really do it there. And we'll go ahead and lock the rotation, pick our end face, and coincident. All right, so demonstrating, so we have those two. So I need the two more. Let's just do an insert component, pick the pin. All right, so unless the mate reference didn't like, so I don't think the mate reference liked that edge. All right, so let's go back and change it. Mate reference gets added as its own as a folder, and the default will set it to concentric. I don't really want it to find tangency in this case, and I can automatically lock the rotation. So we'll make sure to Control S to save that. Let's try the tile vertically again, and we'll zoom up on those two so that when I drag and drop, oh, that one I have to hold the controls. So let's just go back to the insert. Pin, open. Nope, I'm not getting those to jump. All right, so what I'm expecting it to do is kind of snap, but oh, I just wasn't waiting for it. All right, so thought the lock rotation would be in there automatically, but let's see where it threw it. Sometimes the downside is sometimes it does throw it to a strange location. So let's go coincident, and I'll make sure that I'm not doing the same thing here. Oh, and this is one of those cases, well, I grabbed a little too much there. So Control Z, make sure I only have one selected. And we'll just go through the concentric, lock the rotation, find the faces, coincident. All right, so I did want to put, oh, and those didn't pop up. So if we go to the full list of the mates, then anything that is a concentric could potentially, so that one's locked, that one's locked. Oh, so I misread it. Those two pins are able to move because everything else is able to move. Once we put our last distance mate, I want it last for a reason because it's going to be easier to define. So this is going to be our 297 millimeters. So we have the ability to type in the mm, and it calculates our number. So at some point should save this. Yeah, I'm just going to go ahead and call that one good. All right, so now the pins that can rotate, nothing moves. So maybe I didn't see, no, it says that one's good. Okay, don't know why those are underdefined then, but you know, identify it see what's going on with it, move on if it's not cooperating. So the bottom linkage. So let's do a rebuild and let everything, there we go. Everything updates after we do the rebuild. All right, so it goes through and it solves, and we're ready to do our evaluate, mass properties, and the center of mass. Oh yeah, we need to probably switch over to millimeters, grams, and seconds. So it doesn't really matter up until the point where we get to the center of mass. So let's go mass properties, and then we're looking at minus 237, 124.96, and 0. So we're pretty close. Don't know where the other items are, but we get something. We got something close. So the distance mate, and again, the reason I wanted it last is I know exactly where it is. So we can go 420, and if I rebuild it inside of the modify, which I'm not in the habit of doing, but since it's there, we'll go ahead and select it. Look at its mass properties, and we have 0.46. I have 44, 180, 187, and 0. So assuming that I did everything correct and you followed along, then we should be getting those similar numbers. And then the last distance is 612. And if we rebuild that and accept it and do our mass properties, then we have 614. That one's off by quite a bit. 272. That one's a little more. All right, so we're running par for the course. We're close, but we're still getting some variation, and can't say that I'm entirely sure where that's coming from. All right, so let's go ahead and save this, and then we'll go on to the drawing as a separate video.